Hello guys, welcome to this tutorial. So today I'm going to be teaching you how to create a binary counter using the Arduino Microcontroller. So what's a binary counter? Just as the name suggests, it counts binary numbers. So today we're going to be using 4 LEDs to represent 4 bits, more of like 4 spaces. But since we're using 4 LEDs, we cannot be able to represent a large amount of numbers. We can only represent to a certain range, which is from 0 to 15. So if you want to count a number like, let's say 5, it is possible to represent it using 4 bits. So let's get right into it.
Okay, so first thing you want to do is open up the Arduino IDE. If you do not have the Arduino IDE, you can download it from their official website. Just go to Google and search Arduino IDE, and their website will surely be the first on the list. So we're going to be writing Arduino C. It's kind of like a close relative of C. So this is where the logic is done for the Arduino microcontroller. So first thing we want to get ready is our pins. We need to make sure that our pins are ready. So we'll start by calling our pin mode, call on pin 13. We're going to use it as an output, and we'll also call on pin 12. Let's just do copy and paste. Then we set this to 12, then 11, and then 10. That's all. So the next thing we'll do is that we want to create a variable, actually an array of integers, and we're going to make it have 4 spaces to contain 4 values. So we're just going to call the identifier values, pass in 4. I'm also going to create another variable called decimal and just assign it to 0. So we'll head down to our void loop. This is our main code and it's going to run repeatedly. So this is where the logic begins. But before we start writing encode in our loop, let's define a function. I will give it a return type of void, and let's call the function let. So it will be taking 2 arguments, so we'll have to set it up with 2 parameters, which is int n and int value. Now we're going to use the switch statement over here, and we'll just declare the cases down below. So for case 0, we just do an if statement, and then we'll pass in, and for the boolean expression we're just going to pass in value, then close the parentheses. Then we're going to call our method digital write. This method turns the LED on or off, so we're going to call pin 13, and then we're going to make it high. High simply means turn it on with this capital letter, and then else, that is if it is not any number other than 1, then we're going to call our digital write and then make it low with the capital letter. So we're going to use a break statement over here, just so our code doesn't fly from one case to another. So we'll call our case 1, and then oh my, I forgot something, the switch, I forgot to put the argument n. So we'll come back and then do our if. Rather than going that long process, let's just do a copy and paste. It's better that way. Okay, or let's just copy everything including the case, then boom. Yes, so let's go to the first so that we don't get confused. So this is going to be case 1, and then we're going to change it to pin 12, digital write 12 high, and then digital write 12 low, pin 11, then go back to pin 11, and we forgot the case, oh my, change it to 2, and come back, change this to 3, and this is going to be digital write 10, and then digital write 10 with low. So that's it. Okay, let's delete the white space. So that's it for this method. It's going to have a return type of void, and it's going to be taken into 2 arguments, which is n and then values. Int n tells us the nth pin. It can be the first pin, the second pin, the third pin, or the fourth pin. Value is either going to contain 1 or 0. So it tells us whether the pin we are referring to is either on or off. So in C programming, any number other than 0 is referred to as a true. So number 1 is a true, number 2 is a true, but 0 is referred to as a false. So when we pass in value, if it is 1, it's going to be true. It's going to call the function digital right high, and if it's a false, which is 0, it's going to call digital right low. Okay, so let's go into our void loop. So before that, let me change the global variable I declared earlier on. So let's say something like this is something like limit. Let me change it to limit. So I'm going to be using this variable to tell my code how many times the loop has run. And so let's call our do while loop, just because I want this code to run for the first time before then checking my condition. And we'll use the for loop. We'll go with int I equals 0, and then we'll go with if I is less than 4. Since we're going to be using 4 LEDs, we don't want to exceed 4. We want it to loop 4 times, and then we're just going to increment I. Next is we want to be sure that we are populating our array of integers with the required data. So we go with values in bracket, and then we pass in the I. And since we're going to be dealing in base 2, we're going to go with decimal modulus 2. So the modulus operator just returns the remainder after performing a successful division. So we haven't declared our variable decimal, so let's go above and declare it int decimal equals 0, since I want it to start from 0. Or since I already have my limit, let it start from where limit is, since limit is still going to be adding up. Then I'll come back and type in my decimal modulus 2. Then I want to divide decimal by 2 and still make sure I'm getting only the quotient. So I'm going to go with decimal equals decimal divided by 2. Or let's be more flexible. Let's go with decimal divide equals 2. Okay, so what happens here is that decimal is being divided by 2, and whatever value that is gotten from dividing decimal by 2, we just assign it to decimal. Next is we want to declare our condition. So it's a do while loop, and it's gonna be while decimal is not equal to 0. So we want to make sure that when decimal is equal to 0, we just break out of the loop and then proceed to other things. Next is we're going to do our for loop, and we are going to be reading it backwards this time. So we want to make sure that we get the most significant bits, and if you do some binary calculations on your paper, the most significant bit is always at the last. So if you're calculating on paper, you always start from bottom to the top, so that you can get your most significant bit to your least significant bit. So I'm just going to be reading from backward to the first. So while j is greater than or equal to 0, because I want to get the 0th number, and then I'm just going to do a j minus minus, which is a decrement. And then I'll call my function, passing in j to tell me the LED I'm referring to, and then passing in the value of that particular LED. And then that's all. So next thing we want to do is we want to call it delay, so that it can pause, because computers are so fast, and we'll just use 2000 milliseconds, which is synonymous to 2 seconds. And next is we increment the variable limit, and then we're going to make sure that limit does not exceed 15. So we'll go with if limit is greater than 15, close, and then we'll just set limit equal to 0. And that's it, guys. We are done for the software part. Congratulations, give yourself a pat on the back, and phew, that's it. But let's not get so excited. We still have the hardware side to deal with. So what we're gonna do, we're gonna just save, and then we're gonna save it as binary counter tutorial, then all files, and then we just click on save. Okay, so let's head on to the schematics of the project. So I'm using LTSpice for the schematics. So I have already drawn the schematics here. Now our voltage source is going to be from pin 13, pin 12, pin 11, and pin 10, as I have defined in the code. Now it's going to be delivering 5 volts each, and we are going to be passing that voltage to our current limiting resistor, and I'm using 220 ohms resistor because that's just what I have over here, and it's going to be going down to the light emitting diode, which is either going to be on or off based on the array that I've defined in the code. which has the identifier of values. We're just going to be using the integers in that array to either turn the LED on or off. So let's head on to our Arduino.
Okay, so I have already built the project based upon the schematic that I showed you in the video. You can see this is where the voltage is coming in from, and then it's passing through the current limiting resistor, and then we have our LED all lined up over here, and then we have it connected to the ground. This is the wire for the ground. So all we just have to do now is plug in our Arduino into our laptop.
Okay, so now that we've plugged it in, all we have to do is go to our tools and make sure that we are connected to Arduino Uno, because that's what we're using. Then we'll head on to our port to make sure that it's COM3. Actually, that's the only port available. And since all this is set, all we have to do is click on the upload, and you see down here it's uploading, and you can see it blinked. Now it starts from 0, 1, then it goes down to 2, then 3, then 4, and so on, 5, 6, and so on and so forth. So you can take this as the first LED as being your 1, then 2, then 4, down to 8. So since it's 4 bits we are dealing with here, it can only contain 16 digits, which is from 0 down to 1, 2, 3, 10 to 15. So that's how it keeps moving. This is 2, this is 3, and so on and so forth. So basic knowledge of how the breadboard works. So let me just explain that. For the rows, they are not connected. That is over here. The rows are not connected, but the columns are connected. Are you saying? The columns are connected. But in this place where I connected the ground, the rows are connected, but the columns are not connected. That's why you can see I arranged all this. In a row. But in terms of the LED connecting with this to the ground, I arranged them in a column. So I want to say a big thank you for watching this video, and I hope that you have learned something new. So keep on developing. Thank you very much.